This video is part of a self-study course on general brakes theory and operation. It should be used with the General Brakes Theory and Operation Training Reference Book. To achieve maximum learning from this self-study course, follow these directions. At the end of each of the 4 parts, pause the video and answer the review questions. Then read the appropriate section of the General Brakes Theory and Operation Training Reference Book. Complete this self-study course before taking the anti-lock brake self-study course.
I was working the day shift out of robbery when I received a call for a code 711. Felonious donut pilfering with malice and forethought. My job was to stop him. My name is Day, Mayday, and I carry a badge. The perpetrator was attempting to elude me, ignoring traffic laws while trying to escape. Suddenly, he made a hard left turn. I tried to follow. My brakes went up to the job. Somehow I managed to stop the car before it became a decoration on an immovable object. While I was recovering my wits, the perpetrator made good his escape. I radioed headquarters and explained the situation. They immediately issued an APB on the subject's vehicle and dispatched a car to our location. You can imagine my surprise when the chief showed up at the scene. He seemed a little upset. It turns out that the stolen donuts were his. The crime occurred while he was talking to a reporter at the donut shop. He felt the incident would make him look like a fool to the press. I said, "This isn't likely to change anyone's opinion of you." This was apparently the wrong answer. I accompanied the car to the dealership. Once at the dealership, I identified myself and briefly explained the situation to the service advisor. I pointed out that since the brake problem led directly to the escape of a fleeing criminal, I needed to monitor the investigation into the cause of the failure. He introduced me to the brake technician that would be in charge of the investigation. He explained to the tech that I would be following the diagnosis and service of the vehicle closely. As we walked, the tech asked how much I knew about brakes. When I explained that all I knew was that you push the pedal and the car stops, he seemed concerned. He explained that for me to understand the cause of the brake problem, I first had to know how brake systems worked. He suggested that I watch a self-study brake course he had received from Ford, and that's where my brakes education began.
The wheel is one of the most important inventions in history. Its importance to humanity is equaled only by man's use and control of fire. As with fire, the action of the wheel must be controlled. Getting a wheel to roll is important. However, getting a wheel to stop rolling can be even more important. In the past, controlling the rotation of the wheel was relatively easy. That was because the power source of the vehicle also provided the majority of the braking power. But with the advent of mechanical power, control of wheel rotation became more difficult. Let's look at some of the physical forces that affect brake systems. Moving a vehicle requires energy. An engine takes the potential energy of a fossil fuel and converts it into heat energy. The engine then uses pistons and a crankshaft to convert heat into kinetic energy. Kinetic energy is the energy of motion. To move the vehicle, we use an engine to change heat energy into kinetic energy. To slow or stop the vehicle, we use brakes to change kinetic energy back into heat energy. Brakes accomplish this using friction. Friction is the resistance to motion of two surfaces in contact. Friction can be used to change kinetic energy into heat. Brake linings and the rotating brake drums, or rotors, use friction to convert the kinetic energy of the moving vehicle back into heat, thus slowing or stopping the rotation of the vehicle's wheels. Just as important as the friction between the brake linings and the drums or rotors is the friction between the tires and the driving surface. This friction is called traction. Good traction is essential to stop a vehicle safely and effectively. Traction can be affected by many things. Wet or icy roads will cause poor traction. So will worn tire treads. Another cause of poor stopping ability is a load that exceeds the capability of the brake system or tire traction. Early vehicles used linkage cables or rods to apply the brakes. However, as technology improved, hydraulic brakes became the standard. Hydraulics is basically utilizing fluid pressure to do work. An example of hydraulic pressure doing work can be seen in the hydraulic floor jack. Inside a hydraulic jack, the power of your arm forces a small piston down a cylinder against a quantity of hydraulic fluid. This creates hydraulic pressure, which is then sent to work against a larger piston. Because the piston is larger, the applied force is multiplied, and the car rises. The drawback is that the larger piston will not travel as far as the smaller piston. So each time you pump the handle, the vehicle will only rise a small amount. Brake hydraulic systems use the same principle to allow your foot to generate the force needed to apply the brakes. When you apply the brake pedal, the master cylinder converts pedal movement into hydraulic pressure. This hydraulic pressure is then transmitted throughout the brake system. The pressure forces the brake linings against the rotating drums or rotors. This creates the friction needed to slow or stop rotation of the wheels. Hydraulic actuation of brakes has advantages other than its ability to multiply force. One advantage is that pressurized fluid can be sent to all parts of a vehicle through small tubes and hoses. Another advantage is that different amounts of pressure can be sent to each wheel. This ensures that the brake force applied is correct for the vehicle's weight transfer during braking. Now let's answer some review questions to help you assess your understanding of the information you've learned. After a question is asked, pause the tape. Once you've answered the question, restart the tape and compare your answer with the correct one. The first review question is, brake systems convert kinetic energy into what type of energy? The correct answer is that brake systems convert kinetic energy into heat energy. If you answered differently, please review Part 1 of this video. Let's try another question. What are two advantages of hydraulic brake systems? Some of the advantages of hydraulic brake systems are the ability to multiply force, the ability to carry pressurized fluid to all parts of the vehicle through small tubes and hoses, and the ability to send different amounts of pressure to each wheel. If you listed any two of these, you're right. If not, review Part 1 of this training video. Before beginning Part 2 of this video, stop the tape and read Lesson 1 in the General Brakes Theory and Operation Training Reference Book. Now that you have learned some of the physical laws that influence brake systems, let's look at some of the components of a typical brake system. Let's start inside the vehicle and look at the brake pedal. The brake pedal is a mechanical lever that allows the driver to apply force to the master cylinder piston. When the driver steps on the pedal, leverage increases the mechanical force and transfers it to the master cylinder. The master cylinder converts this mechanical force into hydraulic pressure, which in turn activates the brake system. The master cylinder is basically a hydraulic pump. It has a piston in its bore that is forced forward when the brake pedal is depressed. As the piston moves forward, it draws fluid from a reservoir and pressurizes it. Since fluid in a confined space cannot be compressed, this action sends hydraulic pressure to all parts of the brake system. All modern vehicles use dual master cylinders. This means that there is a separate master cylinder piston and separate hydraulic circuit for each set of two wheels. This safety feature provides braking to two wheels even if one of the master cylinder pistons or hydraulic systems is damaged. The brake system uses different types of valves to control hydraulic pressure to the wheels. Some older vehicles may use a metering valve. This valve prevents front disc brakes from applying until the rear brakes begin to work. Another valve is the proportioning valve. It regulates pressure to the rear brakes to provide balanced front-rear brake application. These valves may be housed within a single valve body called the combination valve. It combines the functions of the metering valve and proportioning valves. The combination valve may also contain the pressure differential valve. This valve monitors the hydraulic pressure in the two halves of the dual master cylinder. If there is a loss of hydraulic pressure for any reason, the pressure differential valve will activate an electrical switch. The switch will then illuminate the brake warning light. Another type of proportioning valve found on some Ford vehicles is the height-sensing brake proportioning valve. This type of proportioning valve automatically increases or decreases rear brake hydraulic pressure to match vehicle loading. The lifeblood of any brake system is the brake fluid. This specially formulated hydraulic fluid must meet strict requirements. Brake fluid must have a very low freezing point. And because of the heat created by friction, brake fluid must have a very high boiling point as well. All current Ford vehicles sold in North America use DOT3 brake fluid. DOT3 fluid must never be mixed with another type of brake fluid. It is essential that only DOT3 fluid from a closed container be used. Brake fluid will readily absorb moisture from the air. This moisture will cause corrosion in the brake system. Moisture in the brake fluid will also lower the brake fluid's boiling point. This could cause the fluid to vaporize when the brakes get hot. Vaporized fluid will compress and could cause brake concerns or even brake failure. This is why correct handling of brake fluid is so important. Always use extreme care when handling brake fluid. If spilled, it will damage painted finishes. If brake fluid is spilled on a painted surface, do not wipe the fluid with a shop cloth. Flush the fluid off with water. Connected to the master cylinder through specially designed brake lines and hoses are the disc and drum brake assemblies. Let's look at how these components operate. Disc brakes sandwich a disc commonly called a rotor between two brake pads. The rotor is attached to the wheel and the pads are attached to the brake caliper. When the brake is applied, a hydraulic piston forces the inner brake pad against the rotor. The caliper, which the brake pads attach to, slides along pins or rails. The inner pad is pressed against the inner surface of the rotor as a result of hydraulic pressure behind the piston. This same pressure, pushing against the caliper housing behind the piston, forces the outer pad against the outer surface of the rotor. The friction created by the contact of the rotor and brake pads slows or stops rotation of the wheel. All cars and light trucks currently marketed by Ford Motor Company have front disc brakes. While many Ford vehicles use rear disc brakes, others use rear drum type brakes. Drum brakes utilize a drum which rotates with the wheel. Inside the drum is a pair of brake shoes, which are mounted to a backing plate. A hydraulic wheel cylinder is mounted between the shoes. When the brakes are applied, the hydraulic wheel cylinder forces the shoes apart. When forced apart, the shoes rub the inside of the drum, creating the friction required to slow or stop rotation of the wheel. Both disc and drum brakes have variations that are not covered in this video. See your training reference book for more detailed information. Brake shoes and pads are made by integrally molding or riveting heat-resistant friction material to metal shoes or pads. To do its job properly, the friction material must have excellent heat and wear-resistant properties. This friction material may also contain asbestos. While asbestos works well on brake shoes, it does not work well with the human body. Always wear an approved respirator and safety glasses when servicing brakes. Never blow brake dust with compressed air, and always follow the safety procedures as described in the Vehicle Service Manual. This completes Part 2 of the video. To test your knowledge of what you've learned, here are 2 more review questions. Don't forget to pause the video after a question is asked. Then, after answering the question, restart the video to check your answer. The first question is, what feature of a dual master cylinder increases vehicle safety? The dual master cylinder has a separate hydraulic circuit for each set of 2 wheels. If one circuit fails, the vehicle will still have braking power at the other 2 wheels. The next review question is, what 2 safety items must always be worn when servicing brakes? Whenever performing brake service, you must wear an approved respirator and safety glasses. If your answer to either of these questions was incorrect, review Part 2 of this training video. Before beginning Part 3 of this video, stop the tape and read Lesson 2 in the General Brakes Theory and Operation Training Reference Book.
At this point, the tech came into the room and asked if I was ready to investigate the cause of my car's brake problem. I said that now that I understood how brakes work, I was eager to find out what makes them not work. Like all good investigators, the tech began the investigation by interviewing witnesses. I told him that the brakes were gone. He replied that he appreciated my opinion, but what he needed were, "Just the facts, ma'am, just the facts." The tech asked me if the brake concern occurred all at once, or had it come on slowly. Was there any noise when the concern occurred? Questions like these gave me confidence that an experienced investigator had been assigned to the case. Once at the car, the tech began gathering clues. The idea that an automotive tech gathering clues to determine the cause of a malfunction was new to me. Not wanting to miss anything, I immediately began taking notes. The tech began by checking the brake fluid level and condition in the master cylinder. I had learned that the brake system has a hydraulic system which activates mechanical components, and knew that a lack of brake fluid could affect brake operation. While under the hood, the tech visually inspected other components. He looked for damaged or disconnected vacuum lines, electrical wires, signs of leakage, and anything else that may have an effect on the brake system. This preliminary inspection, he said, helps to determine which components may be likely suspects and which are not. I love the way this man thinks. The tech then said that he was going to road test the vehicle. He didn't think I should accompany him on the road test. However, I insisted on going along. After all, I am the star of this video. The tech said that before he started the car, he was going to verify operation of the brake warning lamp. It was working fine, so the tech started the car and noted that the warning lamp went out after the engine started. He then applied the brake pedal to determine the feel of the pedal. He pointed out that though the pedal was low, it felt firm. He mentioned that sometimes when the feel of a brake pedal changes suddenly, the driver will describe it as lost brakes. He also explained that some customers describe loss of power assist as brake failure. He emphasized that understanding the customer concern is essential when investigating a brake problem. It's possible that the brakes on the police car had not completely failed. It might have been that the brake pedal had dropped suddenly, and I interpreted the pedal drop as a complete brake failure. As we continued the road test, the tech listened for any noises that would give him a clue to the cause of the concern. He asked how long the car had been making that grinding noise. Listening, I heard a noise I'd never noticed before. It's amazing the things you hear when the radio's turned down. The tech then drove on a freeway. After reaching freeway speeds, he applied the brakes several times. He inquired if I had noticed the pedal pulsation that occurred after the brakes warmed up. I explained that I had noticed it, but had never had time to have the problem checked before. After completing the road test, we returned to the dealership. The tech said the next step of his investigation would be to check the car's record. I agreed. Checking records is always a good idea when conducting an investigation. The tech walked over to a computer terminal and typed in the VIN. He said he was checking the vehicle service record, OASIS messages, and TSBs on the vehicle. At this point, the tech opened a service manual and began to read. I mentioned that, unlike what is seen in the movies, good detectives perform investigations by the book. He said the same holds true for good brake technicians. The tech then brought the car into the shop. As he raised the car up on the hoist, he explained that completing the undercar visual inspection may provide essential clues in determining the cause of a brake concern. He then began inspecting the brake lines. He pointed out that he was looking for pinched or damaged lines. He inspected for any visible leaks in the lines or at the junction blocks. He then checked the condition and adjustment of the parking brake cable. He told me that the parking brake cable is subject to corrosion between the cable and housing and must be checked for free movement. Finding no obvious defects or damage, the tech then began to inspect other parts of the car. As he did this, he explained that steering and suspension components may cause a symptom that imitates a brake problem. Again, the tech referred to the service manual. Looking in Group 06 of the service manual, the tech turned to the 3-column diagnostic charts. Using the symptom chart as a guide, the tech found the symptom in the condition column. He then moved to the possible source column to get a list of components that may have caused the concern. After seeing what could cause the condition, the tech looked in the action column to determine what steps should be taken to correct the concern. At this point, the tech brought out 2 respirators. He reminded me that due to the asbestos that may be found in brakes, wearing a respirator during brake inspections is mandatory. Although the mask clashed with my wardrobe, I figured that wearing the mask was better than breathing asbestos dust. Every experienced investigator knows never to take any foolish risks. After marking the wheels to ensure correct reinstallation, the tech took the tires and wheels off the car. After removing the wheels and the rear brake drums, the tech did a visual inspection of each brake assembly. He checked for leaking wheel cylinders or calipers, worn or damaged brake shoes or pads, damaged brake drums or rotors. Inspection of the brake pads and shoes revealed that the lining on one pad had completely worn off. This caused metal-to-metal contact, damaging the rotor. This was the likely source of the noise. He noted that the car had more than 45,000 miles of hard city driving on it, and according to the vehicle service records, had never had a brake inspection or brake service performed. The damage to this rotor was terminal. The tech noted that excessive lining wear was listed as a possible cause for low brake pedal in the symptom chart of the service manual. However, he also noted that the car had brake shudder as well as a low pedal. He said that heavily scored rotors do not always contribute to brake shudder. In order to do the job right, he needed to ensure that this damage caused that symptom as well. Following the procedures outlined in the service manual, the tech checked for excessive runout on the other rotor. Using a dial indicator, he measured the runout of the rotor as he rotated it. Excessive runout could cause brake shudder. He then checked the parallelism of the rotor. This is done by measuring the thickness of the rotor's friction surface in several spots with a micrometer. Thickness variations indicate that the rotor's friction surfaces are not running parallel to each other. This is the most common cause of brake shudder. Since both of these checks were within tolerances, the brake shudder could also be attributed to the other wheel's severely scored rotor.
This completes the diagnostic procedures section of this video. In order for you to gauge what you've learned, here are 2 more review questions. Remember to pause the tape after the question is asked, then restart the tape once you've answered. Your first review question is, what tool do you use to check rotor runout? If you said the dial indicator is used to check rotor runout, you are right. If you gave a different answer, review part 3 of this video. The next review question is, how do you check rotor parallelism? You check rotor parallelism by measuring the thickness of the rotor's friction surface in several places. If you missed the correct answer to this review question, review part 3 of this video. At this point, stop the video and read Lesson 3 in the General Brakes Theory and Operation Training Reference Book. After you complete Lesson 3 and the corresponding review questions, restart the tape.
The tech then started the repairs to the brake system. He pointed out that inspecting components as they are removed is important. Wear patterns of the friction material sometimes indicate a problem not originally detected. The tech stressed that attention to detail is essential when working on brakes. He also emphasized organizing the parts logically as they are removed. This will help simplify reassembly. He said if a part is subject to wear and the service manual contains tolerance specifications for the part, check the tolerances, even if the part looks fine. Wear and damage are not always visible, and checking tolerances is a quick way to ensure that nothing is missed. Using quality Ford replacement parts was another thing he emphasized. If another brake problem occurs because of inferior parts, the labor cost to replace those parts a second time will far outweigh any original savings. While the tech was installing the parts on the vehicle, I noted that he continuously referred to the service manual. He stated that this ensures a fixed right the first time quality repair. There are few things more frustrating than finishing a job only to find out something has been overlooked or forgotten. He explained that an item that is often overlooked by many techs is cleaning and correctly lubricating the backing plates and pins during reassembly. Failure to do this often causes brake concerns that could easily have been prevented. He always ensures that the correct lubricant is used at the appropriate location. After he completed installation of the brakes, the tech began installing the tires. Trying to be helpful, I brought him his impact gun. He said that installing tires is not the time for gunplay. Using impact guns to tighten lug nuts is a common cause of disc brake rotor and wheel rim distortion. Using a torque wrench may not seem as easy as using an impact gun, unless you consider that torquing the lug nuts with the impact gun could cause you to have to do the brake job again. With the brake job complete, there was still one step that had to be performed, the final road test. As the technician drove, he put the car through its paces. He asked me if I wanted to check it out for myself, so I took the wheel. The new brakes had the car responding like a quarter horse. I was complimenting the tech on how well the new brakes worked as we came to a stop at a light. I noticed that the car ahead of us looked familiar. When the driver looked back, his donut lips gave him away. It was the donut snatcher. As the thief sped away, I launched into pursuit. He tried his best to shake us, but my car was more than a match for him. No matter what he tried, I stuck with him like silicone gasket sealant. Finally, he tried the hard turn maneuver that he'd used on me in our first encounter, but this time he got a surprise. When the suspect's door flew open, it quickly became apparent this wasn't his first offense for donut snatching. Considering that he was apprehended by his own seatbelt, I'd say it's not likely that he'd been laid off from NASA either.
This completes part 4 of this training video. Here are a couple more review questions to help gauge what you have learned. The first question is, why should component tolerances be checked even when there is no wear or damage detected visually? The correct answer is that component tolerances should be checked because not all component wear and damage can be visually detected. The final review question is, what type of damage is commonly caused by tightening lug nuts with impact guns? Damage to disc brake rotors and wheels is commonly caused by using impact guns to tighten lug nuts. If you missed either of these questions, go back and review part 4 of this tape. We hope you enjoyed this self-study training video and that it helped you to better understand typical brake systems. We encourage you to also take the anti-lock brake system self-study course. You should now read Lesson 4 in the General Brakes Theory and Operation Training Reference Book.